Okay, so good afternoon, everyone. I guess all of you have solved the basic module that I have given on the WhatsApp. That was the easy one, boards one. Okay, at least you have gone through that, right? And when we talk about this module, okay, this module. So I guess most of you have at least tried, है ना? हम लोगों ने ये सब complete किया था, right? We have completed this till Coulomb's law until this, okay? Now we will be doing electric field and all those things together, but till Coulomb's law, we have completed, right? Hi, Anna. So this was 15.1. Now, when you talk about 15.1, what are the concepts covered, right? We covered the concept of charge, what is charge, right? What are the properties of charges, right? Then we talked about charging, how the transfer of charge takes place, right? By conduction, friction, induction, right? Then types of material based on conduction, which is insulator and conductors. Then force due to point charge, which is Coulomb's law. We studied about Coulomb's law. Then force due to multiple charges, right? Superposition of forces. And now we have covered these four. Okay. Now, as I've already told you, solve it on the regular basis. Do not wait for me. Solve all the problems of in class. Okay, as well as homework. On Monday, we will discuss it. And we'll discuss each and every problem, right? There are PSVs on LMS. LMS पे हमारे PSVs हैं, ठीक है? Level 3 छोड़ सकते हो, level 3 but easy है, ज़्यादा मुश्किल नहीं है इसका. Okay, but there are PSVs on LMS. So if you get some doubts, you can see the PSVs, right? But anyways, we'll discuss each and every each and every problems on DSS on Monday. Okay. Okay. Now, I hope all of you understood the concept that we studied in last class. Anyone have any doubt? Raise your hand, because we spend so much time, 2-3 classes, right? And first topic clear हो गया सबका? Anyone have any doubt in first topic? Khushi is here. Khushi is here. Anaga, Anisha, Anjali, Aryan, Hema. Khushi is not here. Krishna, Mansi, Nidhi, Pranjal, Rahil, Siddharth, Sumaya. Sumaya is also here. Minutha. Sumaya, call our Rajesh sir first, right? Because you haven't filled the admission form, right? He is trying to call you. That's why I'm teaching point 2 now, Aryan. That's why I'm teaching point 2, right? है ना? ठीक है. Don't worry. I'll give customized DPP for you guys. Don't worry at all. ठीक है. That's what I'm saying, right? I'll give DPPs also. Don't worry. ठीक है? चलो. So the concept that we are going to study to is electric field. Electric field. ठीक है? Now, सबको ध्यान दो. सबको ध्यान दो. I hope all of you remember a bit about gravitational field. हाँ या ना? बताओ. थोड़ा बहुत याद है? थोड़ा बहुत याद है gravitational field के बारे में, right? और field के बारे में. Yes. So when you talk about field, I said, sir, what is field? So cricket ground नहीं है sir, जहाँ हम लोग cricket खेलते हैं या basketball खेलते हैं या badminton खेलते हैं. I'm not talking about that field, ठीक है? Right? I'm talking about a field which is due to any object, right? For example, a magnet or a charge or any mass, right? So I can say, okay, field is basically the space, right? Space around a new object up to which it will have its effect. Hi, Anna. Right? I'll just explain again. Sorry. Yeah. So yeah, I was saying, okay, that field is basically what? Tell me. Field is basically the space, right? The space. Just मैं यहाँ पे बोल रहा हूँ, है ना? So if there will be someone who is in the room, right? They can hear me. But if someone is outside, right? ठीक है. Yeah, technically yes. But yeah, but we are not talking about that, right? So it is basically a space around which, right, any object will have its effect. ठीक है? समझ में आया field क्या होता है? हाँ या ना? Tell me. हाँ या ना? So as we discussed already in gravitational field, we have two type of field. What are the two type of field, guys? Tell me, what are the two type of field? सोचो एक बार, याद है? बताओ, समर्थ. Vector field, है ना? Right, and scalar field. Yes or no? Right? Means there will be some field, right? There will be some area in which the direction matters, right? And there will be some field in which direction will not matter. है ना? समझ में आया ये चीज? So यहाँ तक सबको clear है? हाथ चालो, यहाँ तक सबको clear है? Tell me, यहाँ तक सबको clear है? Everyone understood this? Right? Yes, it is pretty obvious, right? Now, example, sir, scalar field example क्या होगा? Temperature field, yes or no? The example of scalar field is temperature field. Temperature field, right? है ना? For example, अगर तुम अपने घर में AC on करते हो, think about it, right? You just turn on your AC, है ना? So after suppose 1 hour, right? Don't you think कि every part of the room will be cold, right? Uniformly cold, yes or no? Tell me, yes or no? Yes, right? So doesn't matter कि तुम कहाँ बैठ रहे हो, ठीक है ना? Right? So mostly it will be cold. So yes, I can say, sir, the temperature has nothing to do with the distance or the direction, right? Doesn't matter where you sit. If you are at the same distance, right? At the same distance, the temperature will be same, है ना? So it has nothing to do with the direction. Okay, that's why it is a scalar field. But when you talk about vector field, so we have field like gravitational field, right? है ना? Then we talk about electrostatic field or electric field, right? And magnetic field. Right? So these are your vector fields because the direction matters. है ना? These are vector quantities. Make sense? Now, when you talk about this vector field, this vector field is also of two types. ये पूरा for example है, ठीक है? This vector field is also of two types. Can anyone tell me what are these two types? Tell me. Can anyone tell me what are these two types? Everyone respond. इसको याद है? Very good, Avas. Very good. Yes. Now, अभी तो बताओ ये जो field होगा ये experience करेगा, force करेगा कि नहीं करेगा? Yes or no? Tell me. Because any object, when you talk about force, right? When you think about the effect is force, right? है ना? So we know the force are of two types. In same way, the field is also two types: conservative and non-conservative. ठीक है? So generally, when we talk about this conservative, non-conservative, gravitational field and electric field, right? Gravitation and electric field are conservative. ठीक है? Gravitational and electric are conservative. ठीक है? Gravitational and electric field. Got it? Right? But when you talk about magnetic field, it is non-conservative. अब फिर तुम जैसे हमको conservative, non-conservative नहीं आता है, तो क्या होगा? Now, याद करो, when you talk about Newton's law of motion, याद है Newton's law of motion जब हम लोगों ने पढ़ाई की थी? So we studied that if there's a force which is path dependent, path पे depend करता है, then it is conservative or non-conservative? Tell me. Non-conservative, right? है ना? So obviously the field, such type of field in which the force due to that field is path dependent, then it is your non-conservative. But if it is path independent, path फर्क नहीं पड़ता, like doesn't matter how the object is moving, right? Doesn't matter कैसे move कर रहा है. जैसे तुम stone है ना, ये stone, suppose ये क्या है? Right? Suppose this is your duster, है ना? This is your duster, right? I hope all of you can see this. Now, if you drop it like this, right? So it will fall down, है ना? in the straight line. But even if you throw it like this, right, it will have different path. Yes or no? Yes or no? Video is not spotlighted. Okay, it is pinned. Okay, right? So I was just showing you this, right? That if I drop this duster like this, the path is straight line, right? But if I throw it like this, the path is curved. Got it? Now, even the path is different, the work done by the gravity, work done by gravitational force is same. Okay? Because it is path independent. Clear हो गया ये चीज? Okay, right? Okay. Now we are talking about this electric field. So I will correlate. ठीक है, हम लोग correlate करते हैं. Now first I'll just take example of gravitational field only because हम लोगों को वो पढ़ा हुआ है ना? ठीक है? Yes, that is your curl of f is equal to 0, right? OS हम लोग बताएंगे. I'm not using these words here because नहीं समझ में आया लोगों को. और line integral of any field is equal to 0. ठीक है? Right? If you want the mathematical thing, so it is line integral of E dot dl is equal to 0. ठीक है? This is the mathematical thing. और curl of field is equal to 0. ठीक है? समझ में आ गया? वैस? ठीक है? Anyways, so when you talk about field, let's start with gravitational field. Gravitational field. Well, field. Okay, सब कोई सोचेगा, एकदम बेसिक सोचेगा. What was gravitational force? Tell me, guys. What was gravitational force? हाथ बताओ. Gravitational force का फॉर्मूला क्या था? Step by step हाथ उठाओ. Everyone. Gravitational force का फॉर्मूला क्या था? Rahil, tell me. Vinutha, Srihari, Shreya. Yes, very good. G, capital M, small m by r square. हाँ है ना? Very good, Anjali. Very good, Samya. Right? And this is equal to what? This is equal to what? एक और बहुत बेसिक फॉर्मूला जो बचपन से पढ़ते आ रहे हैं. What was that? mg. Yes or no? हाँ या ना? Tell me. Or ma, right? ma, right? ठीक है. So अगर मैं तुमसे पूछूं सर what is this g? G का वैल्यू क्या होगा बताओ? Think about it. Don't you think sir g would be f by m? हाँ या ना? Step by step हाथ उठा लो. एकदम बहुत ही इंट्यूटिव होना चाहिए बच्चे की तरह, right? Yes or no? ठीक है? So can I say sir g, which is gravity, is force per unit mass? हाँ या ना? Force per unit mass, which is capital G into capital M by r square. ठीक है? But it is force per unit mass. Now force is vector, so G is also vector quantity. Now it is the acceleration, right? It is the acceleration. Na? What we're talking about is acceleration only in this case. But if you remember, this G is also called as, right? Is also called as what? Gravitational field. हाँ या ना? Right? Or gravitational field intensity. Gravitational field intensity. Yes or no? हाँ या ना? Clear हुआ ये चीज? सबको समझ में आ रहा है? Everyone is getting this? Shreya, Sanya, Samarth, Ronak, Riya, Rahil, Pritam, Pravesh, Krishna, Mansi. Step by step हमको जो पता वहीं से करेंगे. ठीक है? Very good. Now अब देखो. This is about gravitational field. Now can I think about the same when we talk about electric field? सोचो एक बार. बात करें इलेक्ट्रिक फील्ड की, तो हम यहाँ पे साइड में लिखते हैं इलेक्ट्रिक फील्ड. right? Electric field. I'll just write over here. ठीक है? Electric field. रटेंगे नहीं, बहुत बेसिक चीज है, बहुत बेसिक चीज, बहुत बेसिक चीज. Now, what is force between two charges? What is the formula of force between two point charges? Very good, Samat. Very good. Right? Very good. Correct. So electrostatic force is given by K Q1 Q2 by R square. Ayana. Yes or no? Think about it. Yes. Very good, Rohit. Very good, Aryan. Now, if I want to say, okay, sir, what is E? What is electrostatic? Right? Electric field. Tell me, what should be the definition of electric field? खुद सोचो एक बार. Very good, Aryan. Very good. रटना ही नहीं है बिल्कुल. रटना ही नहीं. क्यों रटेंगे भाई? सोचेंगे. Right? Tell me, what should be the formula of electric field? बताओ. यहाँ पे मैंने बोला gravitational field क्या था? Force per unit mass. यहाँ पे क्या आना चाहिए? बताओ. क्या आना चाहिए?
KQ1 by R square.
Please message the chat box, right? Yes, very good. So it is force per unit charge. है ना? Force per unit charge. Yes or no? F by Q. Correct. So force per unit charge is your field. है ना? Now, अब यहाँ पे देखो मैंने Q लिख. Why I have said Q? Because ध्यान दो यहाँ पे ध्यान दो. अगर मैं यहाँ पे Q1 लिखता हूँ, if I'm writing Q1, then this electric field is due to which charge? Tell me. This electric field is due to which charge? ये कॉन्सेप्ट है, बताओ. Very good, Samya. Very good. है ना? Q2. Very good. Because force किस पे लग रहा है? Force किस पे लग रहा है? Q1 पे लग रहा है. तो किसके कारण लग रहा होगा? Q2 के कारण. So this is what? This is electric field due to Q2. समझ में आया ना? Tell me, आया ना? Step by step. And this is given by K Q2 by R square. Common sense. Yes, सही है sir. Into R cap. Nishta, I said that if I'm writing force per unit charge, तो कौन सा charge? सवाल पूछोगे ना सर कौन सा charge? यहाँ पे दो charge है, Q1 है, Q2 है. So if I'm writing Q1, right? Q1, which means force is applied on which charge? Q1, right? अंजलि समझ में आ रहा है? विनुता, हिमा, है ना? Force is applied on Q1. Now force is applied on Q1. अगर Q1 पे force लग रहा है, तो force लगा कौन रहा है? Right? लगा कौन रहा है? बताओ. Q2, right? है ना? So this electric field is due to Q2. So this is due to Q2. ठीक है? समझ में आ गया ये चीज? समझ में आया? Now अगर तुमसे पूछा जाए what is electric field due to first charge Q1, तो क्या हो जाएगा? This is again force by Q2, which is given by K Q1 by R square. R cap. हाँ है ना? क्लियर हुआ ये चीज? ध्यान दो, क्लियर हुआ ये चीज? Right? So can I say, sir, for gravitational, right, EG, gravitational electric field is given by GM by R square into R cap, right? And electrostatic or electric field is given by KQ by R square into R cap. Anyone have any doubt in this? समझो. यहाँ तक में किसको डाउट को अब तक? बहुत बेसिक. See, electric field again same as force OS. ठीक है? Electric field का डायरेक्शन R cap और माइनस R cap होगा डिपेंडिंग ऑन चार्जेस. डायरेक्शन हम स्पेसिफाई कर लेंगे. समझ में आया? सेम एज फोर्स. ठीक है? राइट? सो आई कैन से, वो भी हम बता रहे हैं अभी, जस्ट वो बता रहे हैं. ध्यान दो. नाउ अनलाइक electric field, gravitational field, when we talk about this mass capital M, we know force is always attractive. हाँ ना? Force is always attractive. Means electric field direction हमेशा, ये gravitational field direction हमेशा क्या होता है? Toward the center. Yes or no? अर्थ की मैं बात कर रहा हूँ. Toward the point charge, right? Because mass is always positive. मेक सेंस, राइट? समझ में आया सबको? बट when you talk about charges, है ना, when you talk about charges are not of same type. Charges are positive and negative. Charges are negative and positive, ठीक है? Now think about it. When you talk about positive charge, so यहाँ पे Q क्या होगा? Positive. So Q positive होगा, right? So the electric field will be away from the charge. समझ में आया? ये थोड़ा सा है, उल्टा है, right? Away from the charge. ठीक है? This is the concept. But when it is negative charge, right? When it is negative charge, it is toward. अभिराम, खुद सोचो क्यों? Tell me. The answer lies in the force. Tell me. अब बताओ, जब यहाँ पे नेगेटिव चार्ज है, यहाँ पे पॉजिटिव चार्ज है, तो बताओ what is the direction of force? Tell me. What is the direction of force? Okay, right? Due to this charge. Tell me. What is the direction of force due to this? समझ में आया? ये जो है माइनस क्यू चार्ज, ये जो है प्लस क्यू चार्ज. थिंक अबाउट इट. सो द फोर्स, सोचो एक बार, फोर्स राइट इज इन दिस डायरेक्शन. because of this the force is in this direction. Yes or no? The force on this charge is in this direction. Yes or no? Right? Because of this charge. But because of this charge, force on this is in this direction. Right? Now, अब तुम सोचो, sir, but if I'm writing like this, F is equal to QE. F is equal to QE. है ना? सर, अब देखो यहाँ पे देखो, सिंपल है यहाँ पे. अब E जो है, E, अगर F Q positive, Q is positive, right? Then tell me, F and E will have same direction or opposite direction. Think about it. सोचो एक बार, F और E का same direction same होना चाहिए कि अलग होना चाहिए? If Q is positive, think about it. सेम होना चाहिए. कॉमन सेंस है ना, राइट? ऑब्वियसली कॉमन सेंस, सबके पास कॉमन सेंस है ना. क्यू सर पॉजिटिव है तो एफ और ई का सेम होना चाहिए, राइट? राइट, क्लियर? ओके, नाउ अब हम समझा रहे थे, अब समझो एक बार. अब बताओ, मान लो फोर्स इस पे लग रहा है, फोर्स प्लस क्यू पे लग रहा है ना, फोर्स प्लस क्यू पे लग रहा है. किसके कारण लग रहा है? प्लस आई एक्सिस माइनस आई एक्सिस प्लस एक्स एक्सिस माइनस एक्स एक्सिस. my voice is breaking, guys. Is my voice breaking? Yes? Okay, just give me a minute. Okay, right? Okay, now that's what I'm asking. Think about it. I'm saying, right? What is the direction of force due to this minus q charge? What is the direction of force charge on this plus q? किस तरफ अट्रैक्ट होगा? कॉमन सेंस सोचो, किस तरफ अट्रैक्ट होगा? इधर अट्रैक्ट होगा ना, हाँ या ना? यस और नो? टेल मी यस और. सिंपल, बहुत ही सिंपल सोचना है, राइट? ये चार्ज इस पॉजिटिव चार्ज को अपनी तरफ अट्रैक्ट करेगा, मतलब इस डायरेक्शन में होगा. फोर्स इज इन दिस डायरेक्शन. यस और नो? एंड वी नो इफ द चार्ज इज पॉजिटिव, चार्ज जिस पे फोर्स लग रहा है वो पॉजिटिव है, तो इलेक्ट्रिक फील्ड का डायरेक्शन और फोर्स का डायरेक्शन सेम होगा। हाँ या ना? हाँ या ना? राइट? अब समझ में आया कि इलेक्ट्रिक फील्ड डायरेक्शन ऐसा क्यों है, टुवर्ड द चार्ज क्यों है। क्लियर हो गया ये? अभिराम, यू गॉट योर आंसर? टेल मी अभिराम, you got your answer? Now if q is negative, if q is negative, q negative, then what? यहाँ पे same होगा ना, same direction, same. If q is negative, right, then tell me if q is negative means अब इस पे force लग रहा है, right? Wait some earth, wait, that's what I'm showing you, right? Wait, ठीक है, right? Now think about it. If you talk about this, force on this minus q, force on this minus q. अब बताओ, अब फोर्स इस पे किधर लग रहा है? फोर्स इस पे किधर लग रहा है? इधर लग रहा है, हाँ या ना? फोर्स पे इधर लग रहा है, यस और नो? राइट? बट अब क्या हो गया, ये F इज इक्वल टू माइनस QE हो गया ना, बिकॉज चार्ज नेगेटिव है, तो फोर्स का और E का डायरेक्शन क्या होगा? अपोजिट होगा, यस और नो? फोर्स इधर लग रहा है तो इलेक्ट्रिक फील्ड किधर होगा? इसके कारण अपोजिट, ऐसे होना चाहिए, यस और नो? थिंक अबाउट इट, बिकॉज F इज माइनस QE, राइट? माइनस, चार्ज निगेटिव है तो ये माइनस आ जाएगा, है ना? तो फोर्स इधर लग रहा है तो इलेक्ट्रिक फील्ड डायरेक्शन अपोजिट होना चाहिए इसके कारण। 2 मिनट, 2 मिनट दो अपने आप को, समझो। श्रेया समझ में आ रहा है? प्रियंका समझ में आ रहा है? ओके, आई विल एक्सप्लेन अगेन, ठीक है? मैं एक और एग्जांपल ले रहा हूँ, नाउ आई एम सेइंग, फर्स्ट ऑफ ऑल आई एम सेइंग लाइक दिस, सर फर्स्ट ऑफ ऑल इलेक्ट्रिक फील्ड, मैं समझा रहा हूँ फिर से, इलेक्ट्रिक फील्ड is due to one charge or two charge? Tell me, electric field will be due to one charge or two charge? One charge. Make sense? Right? Anyone have any doubt in this? Means, sir, electric field due to Q1, is basically K Q1 by R square, and electric field due to Q2 is K Q2 by R square. हाँ या ना? Step by step. Okay. Now, if I'm writing this, F is equal to QE. Now, what is this F? Tell me, what is this F? Suppose this is Q1 and this is Q2. Better here, right? This is Q1, this is Q2. So tell me, what is this? F is equal to Q1E. What is the meaning of this? Anyone? Tell me, what is the meaning of this? Force किस पे लग रहा है? First of question, force किस पे लग रहा है? Force is acting on which charge? That's wrong, right? Force is acting on charge. Q1. Q1 है ना? Force is acting on Q1, right? Got it? सबको समझ में आया कॉन्सेप्ट? Q1 है यहाँ पे, force is acting on Q1. Due to electric field of which charge? Tell me. Q2. अब समझ में आया तुमको? अब समझ में आया कि सर ये जो E है, this electric field is due to E2, इसके कारण, right? E2 मान लो बोलूं मैं तो, है ना? And this Q1 is the force on this. ठीक है, सबको समझ में आया ये कॉन्सेप्ट? हाँ या ना? ठीक है, स्टेप बाय स्टेप, नहीं समझ में आएगा पूछेंगे स्टेप बाय स्टेप। ये समझ में आया? ना पूछो एकदम, देखो बहुत छोटा फॉर्मूला है बट इसमें भी कॉन्सेप्ट है। ओके, अब ध्यान दो, अब ये पॉजिटिव है नेगेटिव है, राइट? Q1 पॉजिटिव है, नो इशू सर। तो बताओ फोर्स का डायरेक्शन क्या है? ये येलो वाला फोर्स का डायरेक्शन होगा, दिस इज एफ, ये F1 में बोल रहा हूँ, दिस इज F1, राइट? F1 में बोल रहा हूँ, F1। तो ये F1 है, टेल मी येलो डायरेक्शन, डायरेक्शन ऑफ दिस येलो लाइन, राइट? येलो एरो इज डायरेक्शन ऑफ F1। एग्री साम्या, एग्री? राइट? attractive force है ना, so this will attract this. Okay, now I said sir, since Q1 is positive, right, direction of E is same as direction of F. हाँ या ना? Yes or no? Yes or no? Yes? Clear? Right? So that's what we did, no? That's what we did, right? That's electric field due to negative charge is, tell me, inwards, like, है ना? Inwards means electric field sink in negative charge. Clear हुआ ये चीज? Clear हुआ? Means negative charge act as a sink for the electric field. हाँ या ना? Clear हो गया ये concept? Clear हो गया ये concept? सौम्या, अंजलि, राहिल, प्रीतम, अमीश, अनघा, साम्या। Q1 पे फोर्स लग रहा है तो फोर्स कौन लगा रहा होगा? Q1 पे फोर्स लग रहा है तो फोर्स कौन लगा रहा होगा? Q2 ना? तो E किसके कारण होना चाहिए? ये वाला जो इलेक्ट्रिक फील्ड है वो किसके कारण होना चाहिए? Q2 का कारण ना? समझ में आ गया? Right? So just remember this, that negative charge act as a sink and positive charge act as a source. ठीक है? You just remember like this. Now, if you're getting confused like this, right? Think about it. Suppose, wait. Just remember this, right? Suppose I'm having two charges. है ना? Think about it. I'll draw it. I'll draw a line. Suppose I'm having this, right? Two charges. Okay? We have two charges. Think about it. Okay, right? Now this is your positive charge. This is positive charge. And this is negative charge. Okay? This is a negative charge. Tell me guys, am I audible or my voice is low? Okay, it should be fine now. Okay, it should be fine now. Now, those who didn't get it yet, ध्यान से सुनना, ध्यान से सुनना. ठीक है, स्टेप बाय स्टेप मैं फिर से बता रहा हूँ. पहली बात, ये चार्ज कौन सा है? Q1. Okay, suppose this charge is Q1, पॉजिटिव चार्ज है Q1. ध्यान से सुनना, ये नेगेटिव चार्ज Q2 है. ठीक है, right? So I am saying, sir, I am saying that electric field, right? Electric field right, will originate from positive charge, है ना? Electric field will originate from positive charge, so it will act as a source. It will act as a source, and it will sink at negative charge. So it will be like this. Okay, it will be like this. So the direction of electric field is from positive to negative. From positive to negative. This is the direction of electric field, right? ठीक है, और इधर भी होगा, but I'm just showing this. Now, your question should be, sir, हमें कैसे पता? हमें कैसे पता? So we observed, right? What we observed, sir? We observed the force. We know that force is given by Q into E, right? Now the question is, sir, what is this Q? Sir, this Q is any charge that you are taking. जिस पे force निकालना है. What is this E? Sir, this E is the electric field due to opposite charge. For example, if I want to find force on Q1, then this E should be due to E2. हाँ या ना? Yes or no? समझ में आ रहा है? Now, sir, since this is negative charge, this is positive charge, the force on Q1 is toward Q2. It's this direction, right? Yes or no? हाँ या ना? And since Q1 is positive, I can just say direction of force is same as E2. Yes or no? Electric field due to Q2. That is correct, na? That is the direction of electric field from positive to negative. अब समझ में आ गया निशिता? Nishita, you got it now? Everyone got this concept now? Tell me, everyone got this concept? Okay, very good. Very good. Okay. Now, let's see. Let's see some properties, right? Now, this electric field is due to what? This electric field is due to what? Tell me. This electric field is due to what? Point charge, right? ये point charge है. मैं इतना बड़ा बड़ा दिखा रहा हूँ, ठीक है? But हम लोग point charge की बात करें. Formula जो होगा, है ना? ये formula सबके लिए होगा. This formula is true for everything, right? But this formula KQ1 KQ by R square is for point charge. Okay, right? Now, let's try to solve one problem. Suppose I'm having one basic problem. Okay, one basic problem. Suppose I'm having a charge. Okay, think about it. 3 charges like this. Wait somewhere. Suppose यहाँ पे +1 coulomb है, +1 microcoulomb charge. यहाँ पे -1 microcoulomb charge. So what would be the electric field at this point? What would be the electric field due to point A? This is point A. ठीक है? This distance is given as 1 meter. This distance is also given as 1 meter, and this is your 6 degree, right? ठीक है? Find the electric field at on point A. Find the electric field on point A. पहले ये करो, सामने पहले ये करो, फिर हम समझा रहे, फिर से टेंशन मत, right? जिन से नहीं हो रहा है, पहले बताओ. What is this charge, guys? What is this charge? Tell me. ये charge क्या है? Positive and negative. Think about it. This charge is positive and negative. This charge at point, suppose this is B, this is C. This charge is positive and negative. Positive, right? है ना? Now, if the charge is positive, right? What is the direction of electric field? Away or toward? Away from charge or toward the charge? बताओ, देखो ऊपर. Right? अभी मैंने बताया ना, if charge is positive, then electric field is away from the charge. Yes or no? सबको क्लियर है ये चीज? वेरी गुड सानिया, वेरी गुड कृष्णा, मानसी, रिया, क्लियर है? सो अवे मतलब क्या हो गया? डायरेक्शन क्या हो गया? ऐसा. दिस इज ड्यू टू दिस. हाँ या ना? सो E1 is given by K Q1 by R square. हाँ या ना? स्टेप बाय स्टेप, स्टेप बाय स्टेप, स्टेप बाय स्टेप. Right? Very good. Now, for negative, it is what? Toward the charge or away from the charge? For negative, it is toward the charge, na? Right? Very good, Sanya. Step by step, concept easy hota hai. So, sir, it is like this. It is in this direction. हाँ या ना? So, again, we did the same thing in force, na? We did the same thing in force. Sir, we will make XY coordinate. We will make XY coordinate. Right? We will make XY coordinate. Sir, this is the direction of E1. E1. This is the direction of E2. E2. Right? Yes or no? यहाँ तक सबको समझ में आ रहा है? राहिल, प्रीतम, and E2 is given by K Q2 by R squared. यहाँ तक सबको समझ में आया? बताओ, यहाँ तक सबको समझ में आया? हाँ या ना? मानसी, रिया, प्रीतम, विनुता, हेमा, फोर्स में भी यही किया था ना? डोंट यू थिंक? फोर्स में भी हम लोगों ने यही किया था. हाँ सर, ऐसा ही फोर्स में भी हुआ था सर. द ओनली डिफरेंस वाज यहाँ पे क्यू भी आ गया था, यहाँ पे ए पे क्यू भी था, यहाँ पे क्यू नहीं है. राइट? अदरवाइज सब कुछ तो सेम है. ओके, नाउ ये 60 डिग्री है. इफ दिस इज 60 डिग्री, then don't you think sir this is also 60 degree? So this is also 60 degree. So this is also 60 degree. Yes or no? And this is also 60 degree. Yes or no? Step by step. Right? ठीक है. तो देखो, what is K1? What is K1? K1 is 9 into 10 to the power 9, है ना, into 1 microcoulomb, which is 10 to the power 6, 10 to the power minus 6 by 1 meter, which is 1. So it is actually 9 into 10 to the power 3. Right? Newton per coulomb. Unit is what? Force per unit charge, na? So it is Newton per coulomb. Newton per coulomb. है ना? Right? And E1 is equal to E2. E1 is equal to E2. Magnitude of E1 and E2 are equal because charges are equal. Yes or no? हाँ या ना? यहाँ तक सबको समझ में आया? मैंने बस वैल्यू को लेके कैलकुलेट किया. विनुता, हेमा, you are getting these things. विवेक, विनुता समझ में आ रहा है? सुमैया समझ में आ रहा है? इम्बा, सानिया, रौनक, रिया, है ना? बिकॉज Q1 Q2 इक्वल है ना सर. सर Q1 Q2 दोनों 1 1 है सर, और नेगेटिव की जगह हम लोगों ने डायरेक्शन ले रखा है. सो इफ आई हैव ऑलरेडी टेकन द डायरेक्शन, देन नेगेटिव यहाँ डालने की जरूरत नहीं है. यस, वेरी गुड. राइट? हेमा, यू आर फाइन? यू आर फाइन विद द लैंग्वेज? राइट? विनुता, यू आर फाइन? और are you getting the concept? So I can say that, sir, since Q1 and Q2 are equal, R is also equal, E1 and E2 are equal, right? Then we will take what? We will take the component. So E1 vector is given by, E1 is in first quadrant, so it is given by E1 cos 60 degree I cap plus E1 sin 60 degree J cap. Clear? Everyone clear in this? Component, sir, X component, Y component, and E2 is given by E2. Now this is in fourth quadrant, so X is positive, cos 60 degree I cap minus, but sir this is negative, right? This is Y axis is negative, right? So it is E2 sin 60 degree J cap. Now, don't you think, sir, if you take into component, if you break into component, this component and this component, right? And these two components. So Y component will get cancelled, right? So E net is equal to E1 plus E2 plus E2. Now, if you add these two, X will get added to X, Y will get added to Y. This will get added to this, right? And this Y will get added to this. But sir, positive negative, since E1 and E2 are equal, this positive negative will get cancelled. So E net will be equal to what? This is equal, E1 E2 equal, so it is 2E cos 60 degree I cap. हाँ या ना? Because ये positive negative कट जाएगा because both are E1 E2 are same, value are same. It is 2 into E, which is E का value क्या है? 9 into 10 power 3. 9 into 10 power 3 into cos 60 degree, which is 1 by 2 Newton per coulomb, which is equal to 9 into 10 power 3 Newton per coulomb. सबको समझ में आ गया ये? Everyone got this? Tell me, everyone got this? Take a time, take a time. This is method 2. This was method 2. When our method 1, what was method 1? Sir, E net is equal to what? Root of using triangle law. We're using triangle law or parallelogram law. E1 square plus E2 square plus 2E1 E2 cos theta, right? And since E1 and E2 are equal, it is written as root of E square plus E square plus 2E square. Now, what is the angle between E1 and E2, guys? Tell me, what is the angle between E1 and E2? What is this whole angle? What is this whole angle? 120, na? 120, right? 120. Okay, 120, very good. So cos 120 degree. And what is cos 120? Minus 1 by 2. It is root of E square plus E square plus 2E square into 1 by 2 negative. This is negative, right? So 2 will get cancelled. This negative will be here. So minus E square plus E square will get cancelled. We are left with just E net. So magnitude of E net is equal to just E. Yes, on. Proved. Hence proved. This is your two different methods. This is method 1. This is method 2. This is using triangle law. This is using components of vectors. Any doubt till this point? Tell me, any doubt till this point? बहुत बेसिक समझ में आया? फोर्स के जैसा है, फोर्स निकालने आता है तो इलेक्ट्रिक फील्ड निकालने आता है, ठीक है? The only difference is फोर्स में क्या होगा? देखो, it is same as force, right? So force, when you talk about electric field, it is K Q by R square into R cap, whereas force was K Q1 Q2 by R square into R cap. Otherwise, both will be same, right? When you talk about type of problems, they will have same type of problems. Okay, got it? We will see some easy problems, but ये समझ में आया concept? Everyone got till this concept? Tell me, raise your hand. Everyone got till this concept? Okay, now some properties of electric field. Okay, नाउ थिंक अबाउट इट, सोचेंगे हम लोग, सोचेंगे। पहली प्रॉपर्टी तो हमको ऐसे ही पता है, फर्स्ट प्रॉपर्टी वी नो। व्हाट इज द फर्स्ट प्रॉपर्टी गाइस? टेल मी, what property? Just by looking at this figure, what do you think? What is the first property? Yes, it goes away from positive to negative, right? And electric field is always from positive to negative, right? Okay, it is from positive to negative, positive to negative always. Yes or no? Correct. Now, what do you think about second property? Second property क्या लगता है? Tell me, what is the second property? Think about it. What is second property, guys? Doesn't intersect. Very good, right? Yes. So B is it doesn't intersect. It will never intersect. ठीक है ना? Why it will never intersect? If someone asks you why it will never intersect, tell me why it will never intersect. ठीक है, yes. So it will never intersect. Why it will never intersect? The question is why it will never intersect. Now, if you think about it, suppose, right? If it intersect, right? If any of the two line intersect, what's the meaning of that? Let's make it. Let's make it happen. Okay. Suppose I'm having one electric field like this and other electric field like this. Okay. Suppose. Now at this point, what is the direction of electric field? Tell me. What will be the direction of electric field? Think about it. Think about it. Yes, because now even if it is like this, at this point, right? You're not sure that, sir, it is this direction or this direction. Now, can electric field will have two direction at one point? Think about it. Can the electric field will have two direction at one point? No, it's not possible, right? It doesn't make sense. Got it? Got it? Right? So this is asked in your boards that why the electric field will never intersect each other. It's not just electric field, right? Even the magnetic field will never intersect each other. Why? Because yes, 10th में था ना, है ना? Magnetism, yes, the same concept, same concept. ठीक है? Okay. I hope all of you understood this. Now third property, third one, third property. Tell me, what would be the third property? Now, think about it. Think about it. Don't you think that as it goes away, the field lines, right, are away from each other? Yes or no? Think about it. Or how many of you have seen the sprinkler, guys? How many of you have seen the sprinkler? I hope all of you have seen the sprinkler, right? Think about it. You can imagine the electric field lines as the sprinkler, right? Think about it. Yes or no? Think about it. You can just imagine this like a sprinkler. Okay. Now, if I ask you, sir, where the pressure will be maximum, where the intensity will be maximum, tell me. I'll just say this is point A, this is point B, this is C. Where the intensity will be maximum, point A, point B, point C. Point A, na? Point A. Common sense, right? Point A, yes, sir. Right? Point A. Anyone have any doubt? Sir, anyone have any doubt? That point A pe nahi hoga? And if I ask where the concentration of this field lines is maximum, tell me, where the concentration of this field line is maximum? A only. So can I say, right? Can I say, okay, right? Think about it. Yes. So I can say that field or electric field is stronger. Electric field intensity is more when the electric field of lines are concentrated, or when they are more, है ना? Right? Where the electric field lines will be more, the electric field will be more. समझ में आया सबको? I'm just writing in my language, right? Think about it. हाँ या ना? Right? Clear? I guess this is clear. Okay. Now there are two more properties. Which we'll talk about later, because for that you have to understand the concept of potential. ठीक है? So concept of potential हमको अभी नहीं पता है, तो हम लोग वो दो property भी discuss नहीं करेंगे. ठीक है? Clear ये चीज? Right? तो ये यहाँ तक सबको समझ में आया? बताओ, यहाँ तक सबको समझ में आया? बेसिक्स. अब तक बहुत बेसिक्स कर रहे हैं हम लोग. ओके? ओके, हम लोग क्लास में क्वेश्चन करेंगे, अभी बस थ्योरी देख रहे हैं ना. नाउ माय नेक्स्ट कॉन्सेप्ट वुड बी, जो हम लोग होमवर्क करेंगे, जो मैं तुम लोग को दूंगा भी. अभी तक हम लोगों ने जो इलेक्ट्रिक फील्ड का फॉर्मूला देखा, वो किसके लिए देखा? टेल मी. दिस इज बिकॉज ऑफ which kind of charges? Tell me. रोहित, ठीक है, थिंक अबाउट इट ना रोहित, तुमको इसका आंसर तो मिल जाएगा ना. देखो, do they seem concentric? Tell me, do they seem concentric? They don't even make a circle, right? यहाँ पे straight line है, यहाँ पे और दूर हो गया, यहाँ पे और दूर हो जाएगा. Think about it. In this, you will more farther, right? Like this. Okay, right? Got it? Got it, Rohit? Tell me, Rohit, did you get your answer? Yes. So, yeah. So we know we will start with whatever we learned, right? We learned just two things. Sir, force due to point charge is given by K Q1 Q2 by R square into R cap, and electric field due to any charge is given by KQ by R square into R cap, right? Both are for point charge. Point charge. But what if the charge is not point? What if I'm having continuous charge distribution? Continuous Charge distribution. Charge distribution. Charge distribution. So first of all, we should know what is the meaning of continuous charge distribution. Now, how many of you remember the concept of gravitation that we talked about? Continuous distribution, है ना? याद है? Sir, mass can be linear, mass can be in form of area, or mass can be in form of volume. Yes or no? Right? That's what we did. In same way, when you talk about a line, it is your line charge. Line charge. If you talk about sheet, right? Then it is your area. And when you talk about sphere, right? Cylinder, everything, that would be your volume charge. So we can have three things, right? We can have either linear charge distribution, right? So what's the meaning of linear charge distribution? Means suppose I'm having a charge Q which is distributed over a length L, है ना? Charge Q which is distributed over a length L. This is called your linear charge distribution and it is given by lambda. समझ में आया? This is given by lambda. Yes or no? Yes or no? Step by step. हाँ या ना? Right? Means suppose I'm having this. Okay, I'm having this, suppose rod, right? I'm having this rod, है ना? So I mean to say, sir, in this rod, okay, in this rod, the length of rod is L and the total charge is Q. So that is lambda, means per unit length, the charge is Q. But suppose if I want to take one small element from here to here, small element, and the length of this small element is suppose dx, right? So what is the charge in this small element? Tell me. Everyone, think about it. What is the charge in this small element? Total charge kitna hai? Total charge is Q. Per unit charge is L. So charge in this small element is equal to what? Unitary method, guys. Unitary method. बच्चे की तरह सीखना है. Sir, L length में charge कितना है? Q है sir. Right? So 1 meter में charge कितना होगा sir? Sir Q by L होगा sir. Right? Sir तो dx मीटर में कितना होगा sir? Q by L into dx होगा sir. Yes or no? हाँ या ना? Unitary method. No hi-fi concept. Very basic concept. Yes or no? Right? So can I say, sir, for this dx element, the charge will be dq, which is given by lambda into dx? Yes or no? So I can say dq is equal to lambda into dx. For continuous charge distribution, dq is very small amount of charge which is present in very small length. Agree? Everyone agree? Anyone have any doubt till this point? हाँ चलो. Anyone have any doubt till this point? हाँ चलो. ठीक है? Now this is for linear charge distribution, right? Now in the same way we have area charge or superficial charge. So area. Now for area, I hope all of you know that it will be charge per unit area. हाँ या ना? Charge per unit area and it is called as sigma. It is called as sigma, right? ठीक है? Right? So tell me, in this case, if I'm talking about charge, dq, for a very small area dA, right? So what is dq? Tell me, what will be dq? Don't you think, sir, dq will be sigma into dA? Yes or no? Sigma into dA. Very good, Samarth. right? Same ना, lambda into dx, so sigma into d है, unitary method. सर unitary method सर बचपन से सीखा है सर. A एरिया में Q चार्ज, so 1 यूनिट एरिया में Q by A चार्ज, so और DA एरिया में Q by A into DA चार्ज. बच्चे की तरह सीखेंगे सर. Anyone have any doubt in this? यहाँ तक मुझे दिक्कत है? Anyone have any doubt till this point? Right? But there's one more catch. One more catch is, sir, what about DA, sir? What is DA? DA is change in area. Change in area, right? So generally we talk about sphere, circle. We generally talk about circle. Okay. So for circle, this DA is 2 pi r into dr. ठीक है, ये होता है 2 pi r into dr. Because think about it, if I'm having circle, right, एक छोटा सा जो एरिया होगा वो कौन सा होगा? ये वाला एरिया होगा, this area, and this area is given by this circumference into this dr, right? So ये अभी याद रखना, ठीक है? This dA is 2 pi r into dr for circle. We will just talk about circle, ठीक है? Right? ये काम आता है. This is r, and this small change in radius is dr. Now for volume, tell me what is the charge density for volume? Tell me. For volume it will be what? Everyone. प्रीतम बताओ वॉल्यूम के लिए क्या होना चाहिए? It is Q by V, volume, and this is given by rho, right? ऐसे rho बोलते हैं. ठीक है, तो इस केस में क्या होगा सर? V वॉल्यूम के लिए Q चार्ज 1 Sorry guys, my disconnected. Wait, am I audible now? Am I audible now? Okay, so yeah, I was saying the same thing. I was saying that for volume charge distribution, right? Q by V, charge per unit volume is given by rho. Means एक पूरा sphere है. Suppose this is whole sphere. पूरा sphere है. पूरे sphere पे तुम charge डाल दोगे, right? Then charge per unit whole volume is given by rho, which is your volume charge density. This is your volume charge density. Volume charge density. Charge density. Right? है ना? So अगर तुम किसी भी छोटे वॉल्यूम की बात करो, suppose you take any small volume, right? छोटा सा volume. So dq in that small volume is given by rho into dv, है ना? And for sphere, this dv is given by 4 pi r square into dr. ठीक है? Right? Everyone got this? Everyone got this? Tell me. यहाँ तक सबको समझ में आया? Okay, right? So that's it for today's class. ठीक है, आज के लिए यही करते हैं. ठीक है. Now homework would be just revision of this. Homework would be just revision of this and some basic questions that I'll send. ठीक है. कुछ बहुत basic questions मैं करूंगा, दूंगा, उसको solve करना है. ठीक है. I'll send it. I'll send this. I'll send this also. मैं बताता हूँ tomorrow कल किसका क्लास होगा. मैथ्स का अब तक सिर्फ एक क्लास हुआ ना. मैथ्स कितनी क्लास में? एक क्लास, राइट? So most probably tomorrow would be maths. दो क्लास एक ही दिन में ना. टू क्लासेस वन डे, और है ना? हाँ, then tomorrow would be maths for sure, maths 5 would be sure. ठीक है, I'll send this, don't worry, I'll send this. टोटल जो है ना, मैं जो जो लिखता हूँ ना सब मैं भेज दूंगा, ठीक है. ओके ओके, अरे I'll tell you, ठीक है.